All right, we're on. So we are doing now section 13.1. Well, actually, we were doing section 13.1 before. But now we're just continuing, right? So this is like part something, 4 or something like that. Well, anyway, let's do this. Let's grab a triangle. And we're going to talk about, now, just like yesterday, this is a lot of review of geometry, when we did that trig chapter in geometry class. Do you remember doing that last year?
Yeah.
Yeah.
I remember that.
I mean, most of you guys were in my class last year. All right, so here we go. We've got a big triangle right here, and it's a right triangle. You know that because of that little square right there. All right, and we're going to say that this side is congruent or equal to that side right there. So first of all, because the sides are congruent, a little review from geometry. What's the name of that triangle? It's an isosceles triangle. It's isosceles. It's a right triangle, so it's an isosceles right triangle. And we also learned something else. If it's a right triangle, then these two angles, we talked about this yesterday. Yeah, they're congruent because they're opposite the equal sides. That's true. They're also complementary, aren't they? So complementary, congruent, or I should say this, congruent complementary angles would be equal to what? 45 degrees. Okay, so you do remember stuff from last year, don't you? All right, so that's 45, 45. So, do you remember last year? It's not much of a leap here in naming this thing. What do we call it? A 45, 90 triangle. Okay, not brain surgery yet. Okay, so there you go. So we call that. Now we had a relationship. Now I want to stick with the book. Okay. Since these two sides are equal to each other, we'll call this side x and we'll call this side x. Now here's a real stretch to see if you remember something from last year. There was a relationship between the hypotenuse and one of the sides, or either one of the sides, because they're both the same. What was that relationship?
X times the square root of 2.
Okay, it's times the square root of 2. Remember, we wrote it down like this. We said the hypotenuse is equal to the square root of 2 times one of the legs. Does that look familiar?
Yeah.
Who had me last year? Right, but according to this, just like Dallas said, it's the square root of 2 times one of the legs. One of the legs right here is x, so of course, what would this be? Square root of, yeah, x squared root of 2 or square root of 2x, however you want to write it, doesn't make any difference. All right, we good so far? Now, why are we doing this? This is a whole trig thing, isn't it? Remember we did the trig stuff? Well, what we're going to do is we are going to actually find, this is a special triangle. These are triangles that show up quite often, and it's nice to memorize some of the things. We're going to come up with something that we're going to memorize. So, if I'm going to find the sine of 45, now if you have your calculator, you can always put that in a calculator, figure out what the sine of 45 is. But we're going to take the knowledge that we already know, and we're going to figure out what the sine of 45 is. It doesn't matter how big our triangle is, does it? Because 45 degrees is 45 degrees. No matter if it's a triangle, this size, or a triangle that's smaller or bigger, it's still going to be 45 degrees. Agreed with that? Mm-hmm. All right. So the sine of 45 will always be the same no matter how big or small the triangle is. So let's, because it's a relationship. It's a relationship between the what side? Opposite side over the hypotenuse, right? That's what the sine is, remember that? So, katoa, S-O-H, opposite hypotenuse. All right, so the sine of 45 is the opposite. So let's use this one. We could use either one, doesn't matter. The opposite is x, and the hypotenuse is the square root of 2 times x. Let's simplify that. What happens with the x? Cancel each other out, right? So you get 1 over the square root of 2. We simplify that because we don't like the square root of 2 in the denominator. So we write the square root of 2 over 2. That's the sine of 45 degrees. Punch it in a calculator. See it. Who's got a calculator on them? Elizabeth? I think it's like 0.707, isn't it? Okay. So you put sine of 45 in? Is that what you got?
I just did.
Oh, you did square root of 2 over 2, right. Square root of 2 over 2 is 0.707. Punch in sine of 45. It's 0.707, isn't it? Okay, so they are equal to each other. Yes? Because I multiply the top and bottom by the square root of 2. I just did that in my head because we've done that a lot. Right? Multiply the top by square root of 2. And the bottom. Right, you can't have the square root on the bottom. Remember doing this, multiplying top and bottom by the square root of 2? You don't? Yeah, well, we did it. We did a bunch of this. So you multiply it by square root of 2 on the top and the bottom. And why can you do that? Just as a reminder, Because what's the square root of 2 over square root of 2? So 1. We can multiply anything by 1, can't we? So we multiply the top and bottom. That gives you the square root of 2. Square root of 2 times square root of 2 is just a 2. So that's why we did that. All right? Okay. Joel? No. I'm serious. Just hang on. Is it an emergency? Is it an emergency? You can't wait 2 minutes?
Can't wait till it's on there.
Huh? Sure you would. People ask me all the time. They don't really have to go.
Yeah.
All right, let's keep going. Oh, there goes my pen again. How did I do that? No, I'm
Are
not
you
going
pushing the
to.
button?
Yeah, I'm pushing it.
I'm talking about on the pen.
So you like the right.
No, I'm not pushing the button. I don't need to push the button on the pen.
And you like move it on.
Move it over here. I'm going to have to.
You just move it on
Edit
the mouse
this.
pad. Can you move it on the mouse pad real quick? Because it seems like whenever it's over a button. Yeah.
Is that what it is? Okay. Oh, okay. So I use the mouse pad to move it over.
Yeah, whenever it's over a button.
Okay.
it doesn't work.
Ugh, I'll have to edit that. Maybe I won't. Who cares? Khan didn't, right? He sneezed in the thing and let it stay on there, didn't he? Remember that
No,
one?
I
He
didn't watch
started.
all of his videos.
He burped? Did he really? Yeah, I didn't hear. I think he sneezed at one right at the beginning. He says, "Oh, excuse me, I shouldn't have started off like that." So I'm like, well, if Khan can do it, I can do it. All right. So anyway, what are we doing now? Let's do the cosine of 45. Look at the cosine. It's adjacent over hypotenuse. It's the same exact thing, isn't it? All right, because it's adjacent, which is x, over the hypotenuse, which is the square root of 2x. Works out exactly the same. I don't have to go through all that again, do I? I see that it's exactly the same thing, so it's square root of 2 over 2. Try that on your calculator when you want. Try cosine of 45. It's the exact same thing as the sine of 45. Now let's do tangent, because we have to get through it. 30, 60, and I only got a few minutes. The tangent of 45 is opposite over adjacent. So x over x, which is what? 1. Punch that in the calculator. Tangent of 45, you get 1, don't you? These are things, now right now you probably don't have to memorize these. Eventually we're going to get to a point where you want to memorize this. The sine of 45, cosine of 45. You don't really need to right now. This is kind of an introduction to it, but there's definitely a place a little bit later where we're going to memorize those.
Wait.
All right, let's do another one. What?
You're
Quickly.
just forget how I
No, say it.
Alright, you try to find the tangent. What are you finding the tangent of though?
The tangent of 45 degrees. I wrote it on there. I put tangent of 45 degrees.
Yeah, I understand that, but like, are you trying to find the sides of x?
Trying to find the tangent of 45, the opposite over the adjacent. You're trying to find what the tangent of 45 is equal to without using a calculator. Okay, so you got the 45 degree on there, right? So the tangent of 45 is the opposite side divided by the adjacent side, which equals x over x. And what's x over x? It's 1. So the tangent of 45 equals 1. You don't see that?
Are you looking
We'll talk about that later.
He's just trying to find the tangent of 45.
Just trying to find the tangent of 45 is all I'm doing. Okay? Now watch this. What do you think I made this? We had 45, 45. What do you think this is? What is it? 30, 60, 90. Correct. Jamie from the back. All right.
Okay, that was good.
Okay, so that'll be the 30, and this will be the 60 right here. We got to go a little quicker. I have a minute and a half because I got to go 10 minutes on this thing. So remember what we referred to. This is the hypotenuse right here. This is the, yeah, it's a leg. That's true, but in reference, what do we call it? It's the short side. It's the short side. You remember that? This is the short side, and this is the long side, and this is the hypotenuse. Good. All right, so let's do this. Let's make the short side x to make this kind of easy. Now, there's a relationship. Remember the relationship on a 45, 45, 90. That was the hypotenuse equals the square root of 2 times one of the legs. But on a 30, 60, 90, they both relate to the short side. Okay, so the hypotenuse, this is what we wrote last year. The hypotenuse is the twice the short leg. And we'll put in the letters and stuff over here in a second. Then we said the longer side is, what was the number? Do you remember that? Square root of 3 times the short side. See, they both relate to the short side. So if you know the short side, you can do everything else. So watch, if this is x, this is the hypotenuse, it's what? It's twice as big, so it's 2x. This is the longer side. If this is the short side, then this is, yeah, x squared of 3. I like to write square root of 3x, and there you go. I'm going to have to continue on the next one. So let's stop.